Okay, these are our 4-4 graphing function notes. These are given on Tuesday, October the, I think the 5th. Let's see. Yep, Tuesday, October the 5th. So a lot of the work that I'm going to do with these notes, I'm going to actually be graphing on the calculator. And so I'll allude a lot of times to the calculator. If your student has one, that's fantastic. It is very, very helpful, although not mandatory for the class. It's a worthwhile investment that they can use for a long time, all through high school and through college. However, there is one here on the website. If you go to the textbook website, there is a graphing calculator they can use there as well. So anytime we're going to graph a function, our equation has to be in y equals form. And if it isn't in y equals form, then we have to solve it first. So this first example that we have, our equation is not solved for y, so we're going to solve it for y by moving our x, and I'm going to make this 1x. We're adding the x because it's negative, and so the opposite would be adding. You get 2y equals, now we can't add 6 plus 1x, so we're just going to simply write 6 plus 1x, and then if we divide everything by 2, we get y equals 3 plus 1/2 x. So at this point, the students would go to the calculator and type in y equals 3 plus 1/2 x on their y equals screen. When you type in on the y equals screen, your function is going to look like 3 plus, and then 1/2 is a fraction written in parentheses, and then the x goes on the outside. So basically what they're doing is they're typing this in so that they can get the values that we're going to graph. The domains, our x values, are -4, -2, 0, and 2. And they don't have to have a calculator to do this. You can take each one of these domain values one at a time and plug them in for this x right here, multiply it by 1/2, and then add the 3, and that will also get the answer. So certainly fine to do these by hand. We just usually do them on the calculator to make ourselves more efficient, just a little bit more efficient. So if I plug all those in, let's see, I'm going to try to work these in my head real fast. -4 times 1/2 is -2, plus 3 would be 1. -2 times 1/2 is -1, plus 3 is 2. 0 times 1/2 is 0, plus 3 would be 3, and then finally 2 times 1/2 would be 1, plus 3 is 4. So those are our domain and range values, our x's and y's, and they create ordered pairs. You go to -4, 1, 2, 3, 4, and then up to 1. You go over to -2 and 2. I'm going to actually, let me redraw those dots. Sometimes it doesn't line up just correctly. Let me see if I can get a little bit closer. 1, 2, 3, 4, 1, right here. 1, 2, -2, and then up to 2 would be about here. And then 0, 3 would be there, and then 2, 4 would be up here. And we notice this makes a wonderful straight line, so the way you graph it properly is to connect all the way from one side of the graphing grid to the other and put arrows on the ends. Because this problem has just a plain x in it, we know that it's from the linear family, and we studied our families. Linear, sorry. We studied our parent function families on Monday of this week, and there's a notes video if you need to watch that over parent functions. It's quite good. It lets the kids know what kind of graph they're dealing with just by looking at the information. All right, let's go to our next page now. This again is another one that isn't solved for y, so if I take a moment to fix it, 1x minus 3y equals 6, -6. I'm going to move that 1x. I'll get -3y equals -6 minus 1x. Divide everything by -3. And I end up with y equals 2 plus 1/3 x. We've been solving for y for quite some time now, so most of the students are getting the hang of it. They're doing pretty good with it. Our table, x and y, they gave us our domain of -3, 0, 3, and 6. And if I plug each one of those values into the calculator, or just into this x right here, because that's fine as well, -3 times 1/3 is -1, plus 2 is 1. If I put a 0 in there, I get 2. If I put a 3 in there, I get 3. And then if I put a 6 in there, I get 4. So again, linear family, because we've got a regular x in our problem, so I know I'm going to be creating a straight line. -3, 1, 0, 2, 3, 3, and 4, 5, 6, and 4. Connect them together, put arrows on the end, and there you've got your graph. Now our next one is wonderful because it's actually already in y equals form for us. F of x is a fancy way to write y, so you've got y equals x squared minus 3. And we learned on Monday that anything with an x squared in it is going to be from the quadratic family. And quadratic family graphs look like a U. So I'm going to erase this work I've got here in the center just to make myself some more room for my table. And I'm going to draw my table, x and y. My domains this time, my x's are -2, -1, 0, 1, and 2. They're just selected dots on the graph. You could choose a different domain if you wanted to, but those will make our graph look nice and pretty as we plug things in. So if I plug in a -2 for the x, I'm going to square it and then subtract 3. So -2 squared is 4, minus 3 would be 1. 1 squared is 1, -1 squared is 1, minus 3 would be -2. 0 squared is 0, minus 3 would be -3. 1 squared minus 3 would be -2. And 2 squared is 4, minus 3 would be 1. So we kind of notice as we write these values right here, they kind of started going down and then they repeated and scooped back up again. That's classic of a parabola or a quadratic family graph. So when I draw them, I'm going to be able to see the U pretty clearly. The kids can go to the calculator and look at the table the table screen that will give them these values, but then they can also go to the graphing screen and it will show them a nice picture. The only thing about doing that is you want to make sure that you always plot your points and then graph. Don't just draw a line on the graphing grid. It has to be perfect, so you need your points there. So -2, 1, and -1, -2, 0, -3, 1, -2, and 2 and 1. And those are our dots. Now we know this is a U, so we want to make it look as U-shaped as possible. I'm going to start up here at the top, curve down and catch all those points, and then put my arrows on the end. I kind of missed that little guy at the bottom. I probably need to make that graph just a little bit deeper, but we want to try to be as neat as we can with our graph. So if you have to erase and start over again, that's fine. As a matter of fact, I'm going to do that. I'm just going to get rid of my little bottom part here, redraw my point, and curve that thing around so it looks good. Fantastic. There we go. All right, let's look at example C. Example C is another one that's nice. Already in y equals form, absolute value of x plus 2. So I've got my domains, and I'm going to find my ranges, -2, -1, 0, 1, 2, and 4. Got several values this time. If I plug each one of those values into absolute value, it makes them positive. If they already are positive, then they stay positive. So -2 absolute value plus 2 would be 4. -1 absolute value plus 2 would be 3. 0 absolute value plus 2 would be 2. 1 absolute value plus 2 would be 3. See how we're starting to go back up again? 2 absolute value plus 2 would be 4. 4 absolute value plus 2 would be 6. So we kind of started going down, and then right here it started changing directions and going back up again. An absolute value graph looks like a V. So like the parabola, it does change directions, but it changes directions very sharply and crisp. It should be a perfect V graph. So our families were the linear, which has a regular x. We had the quadratic. Whoops, my pen's messing up again. Hang on just a second. Oh, there we go. Sometimes it just likes to quit working in the middle. Quadratic, which is x squared, and then we have the absolute value. Sorry about that. Which is the absolute value of x. So those are the three families that we worked on this week, and it's nice to know because then if I look at this problem right here, I know it's going to be a V graph because I see the absolute value in there. All right, let's get this guy drawn. -2 and then up to 4, -1 and up to 3, 0 up to 2, and then 1 back up to 3. So see how my, whoops, I think I did my graphs wrong. Oh, I got some dots off. Try it again. -2, sorry guys, 1, 2, 3, 4. Oh, now I'm up high enough. -2, 4, -1, 3, 0, 2. Now I've got them right. 1 and 3, 2 and 4, and then 4, 1, 2, 3, 4, and 6 would be way up here. And they make this perfect, wonderful V, super sharp down, super sharp up, and then of course you have your arrows. All right. On the back page, we started graphing functions that don't give a domain. So what the students are forced to do is go to the calculator and find some domain values of their own. It's a little, they're not harder, but it's just a little more thinking on their part. And again, if they want to not do the calculator, if they want to do these on their own, they certainly can. The table feature on the calculator really helps. All right, so I'm going to do example A. This is linear, I know, because I see a regular x in the problem. If it's linear, you don't really have to worry about choosing a good or a bad domain. It's going to be straight line, so it really honestly doesn't matter which values you choose. I'm going to choose -2, -1, 0, and 1. I've just picked 4 random values because they're around the center. And if I go to my calculator and I type in -3x and then +2, and I press second graph to get my table, I'm going to see that -2 goes with 8. And -1 goes with 5, 0 goes with 2, and 1 goes with -1. So my -2 and 8, 1, 2, 3, 4, 5, 6, 7, 8, way up here. And then -1, 5, 1, 2, 3, 4, 5. 0, 2 would be right here. And then 1, -1 would be down here. I see it's linear. I can look on my calculator and see that it's linear. I know it's linear because I've got a regular x. Connect those guys together. Ooh, try to get that line as straight as you can and put your arrows on the ends. What kind of family is that? Absolute values. So I'm going to put my x and y. And this time I'm going to go to the calculator and type in the absolute value. And I'm going to look to see if I can see that change. Back on the other page, I'm going to go back for just a second. Back on the other page, remember when we noticed this change over here, how it started going back down, or it went down and it started going back up? That's what you're always looking for on the calculator. That will help you to construct a good graph or a better graph that will help you to draw a better picture when you start actually plotting the points. So I'm going to type in x minus 1 absolute value onto the calculator and press second graph to get to my table. And of course you can't see this, I'm looking at a calculator right now, but if you're looking at a calculator, I am seeing a change occur when my x is a 1. I see it's 0, and then everything from there goes up, and then the other side of it was going back up as well. So I'm going to choose 1 as my x value right in the center. But I'm also going to do 0 and -1 on this side of it, and 2 and 3 on this side of it. Now, you can choose any values you want to. The thing you have to be careful about, let's say, for example, that we have a graph that's absolute value. It's a V. And let's just say I had some dots. I'm just making up a random example here. I'll erase it in just a second. Let's say I had dots that were looking somewhat like this, and I connected them all together and made what I thought was a linear. Well, if I'm not careful with the values I choose for domain, this graph may be going back up this direction. And I should know that because it's absolute value. And in fact, it should look like this, with that part not on there. So that's why you have to be careful in choosing a domain, that you pick one that makes your graph look great. So my values I picked were 2 and 1 and then 0 and then 1 and then 2. So I see how the change was made from going down and then going back up again. -1 and 2, 0 and 1, 1 and 0, 2 and 1, and then 3 and 2. So I've got my nice little V. I know it connects all the way out this way, comes all the way up that way, and of course then you have your arrows. Finally, on our last one, what kind of graph is this? It's quadratic because it's got an x squared. So I'm going to put my x and y table, and again I'm going to go back to my calculator. I'm going to type in x squared plus 4. And when I look at my table, I'm going to see if I can see that shift, that transition. Oh, this is a nice one. 0 is kind of going to be the middle point. That's where the curve is. So I'm going to do -1 and 2 and +1 and 2 as my x's. If you don't really understand how that's working on the calculator, you can come in for tutoring and I'll help you. But also, you can just pick some values. You know it's going to be a parabola, so if you pick a few values and you don't really feel like you have enough, then you can pick some more. Just keep on plotting until you get a nice little picture. And then, of course, I see there how my line changed. So -2 and 8, let's see, 2, 4, 6, 8. 1 and -1 and 5, 0 and 4, 1 and 5, 2 and 8. And that's probably way up in the air this time. And there you go. That is how to graph a function.